All right, y'all. So like I said, 2.4 deals with the algebra of functions. So we'll look at some notation they use for adding, subtracting, multiplying, and dividing. So y'all, the first one will be f plus g of x. So if I'm given two functions and I want to add them, I can use this notation. But f plus g of x equals f of x plus g of x. Now, the thing you got to remember when we're adding, we cannot change the way the variables look. Okay, so you can add variables together if they are like terms, but you cannot change them when you're adding. And that'll be the same thing with subtraction, which is f minus g of x. That'll be our f of x minus our g of x. And y'all, once again, when you're subtracting, you cannot change the way the variables look. All we can do is add our like terms together and be done, okay? Now, subtraction is a little bit trickier than adding because when you got subtraction followed by parentheses, we're going to have to distribute that subtraction through, just like in that support assignment, okay? All right, so next would be multiplication. So that'll be f times g of x. And y'all, that's just two functions being multiplied. F of x times g of x. Now, multiplying variables, we will change exponents, okay? So recall the rule for multiplying variables. X to the m times x to the n. When I multiply variables, I'm going to add their exponents. Okay. Also remember this. If you just got an x sitting there, that's like an x to the first. They do not write an exponent. It is understood to be a 1 there, okay? All right, so that's what I'll do when I multiply the variables. I'm just going to add their exponents. And then finally, we got f divided by g of x. So that'll be my f of x divided by g of x. And y'all, we've also learned this week that g of x cannot equal what? Since that g of x is in bottom of that fraction, what can our g of x not equal? All right, y'all, let me get my chat pulled up. All right, good job. It is definitely cannot equal 0. Good job. So y'all, these are the 4 operations. They'll give us 2 functions, and they're going to want us to either add, subtract, multiply, and divide. Sometimes they'll give us numbers in place of the variable, and we'll have to plug that into our functions and solve that doing our order of operations, okay? So if they don't give you numbers to replace it with, all we can do is simplify the expressions. If they do give me numbers in place of the x's, then I'm going to evaluate that all the way down to a single answer, okay? All right, y'all, so let's see how these little exercises are going to go. So for my first one, I'm going to be given f of x equals x squared plus 1. G of x is going to equal x minus 2. They want me to find f plus g of an x. So they're not giving us the variable, number to put in for the variable. So we're going to find f plus g of x. F plus g of x. And y'all, I'll tell you a little trick I do. No matter what operation I do, I put my functions inside parentheses. So I'm going to put my f of x plus my g of x. So f of x, I'm going to put an x squared plus 1. And then g of x, I'll put in my x minus 2. So the thing about adding, when you're adding, we can drop our parentheses and everything will stay the same sign. So x squared plus 1. And then dropping these parentheses will give me a positive x minus 2. Okay, so pluses are like positive ones. So positive times a positive stays a positive. Positive times a negative stays a negative, okay? Now, at this point, all we can do, like we said up here, was add like terms. Well, y'all, the only like terms I got are the numbers. So coming down, x squareds only add the x squareds, y'all, and I don't see no more x squareds. So I'm going to bring down that x squared. Next, I would put the x, because I'm going to sort of put them in descending order. And MathLab will make y'all do this too. So then the x will come down because it's not got nothing to add to. And then let's see, Catherine, what you got? X squared plus x. And then you added 1 and negative 2 and got a negative 1. Good job. So remember, we said when we're adding, we will not change exponents on those, okay? Just add the like terms and you're done. All right, so if we want to change exponents, this next one we can do that because they're giving me a little bit of multiplication. So this one I'm given, let's see, f of x is going to equal x squared minus 4. G of x is going to equal x minus 2. So y'all, they want us to find f times g of x. So still not giving me numbers to put in. So the only thing we can do is try to multiply them and then simplify, okay? So we're finding f times g of x. So f times g of x will equal my f times my g. Y'all notice parentheses back to back mean multiplication also, okay? So f was the x squared minus 4 times my g, which is x minus 2. All right, y'all, let one in real quick. All righty, so a little bit of multiplying going on here. So f times g of x equals x squared minus 4 times x minus 2. Y'all, this is where y'all would have heard terms like FOIL. When you got two things times 2, FOIL is the easy way to remember that. You got to multiply 4 times. because there's 4 letters. But I'll sort of show you what they mean by this FOIL. So the F means the first thing in each parenthesis. Well, that's taking this x squared and multiplying by that x. So if you multiply x squared times the x, what will that give us? So now y'all got it. Good job. Now we're going to get the x cubes, right? So that'll be my x cubed. And remember, this one didn't have an exponent. We said up here it was a 1 if it didn't, okay? All right, so the first one in each parentheses was the F. The O is the outer two most terms. The outermost is the x squared and the -2. So I'd multiply them next and get a -2x squared. So when you multiply a number times a variable, you end up with the number and the variable still, okay? So y'all, that was the O, the outermost. The I is the innermost. So now you're starting to multiply -4 times stuff, okay? So this -4 multiplies by the x, and that's just going to give us a -4x. And then the L is the last one in each parenthesis. So now we're taking the -4 times the -2. So -4 times -2 will give me a +8. Oh, Taylor, you were so close, except at the end, it looks like you took the 2 times the x squared again, but you should have took that -2 times that -4 and made that a +8, okay? So really the trick on this, y'all, is you distribute the x squared through the parentheses, and then you're distributing the -4 through the parentheses, okay? Now, this one don't have any like terms, and it's in descending order. So y'all, that would be our final answer. So yeah, be careful. Because remember that x squared, we already had multiplied by the -2 on that one, okay? All right, y'all, so let's play with this next one and see what they're doing here. So this one we're given f of x equals x squared minus 4. G of x equals x minus 2. They want us to find g times g of x. All right, so a little multiplying again. So I'm going to come over here and do my g times g of x be my first function times my second function. So y'all, what I would ask on this one, what would y'all put into this parentheses, and then what would y'all put into that parentheses? What are we even going to put into these two sets of parentheses? So the first one, y'all got an x minus 2. Oh, you got x minus 2 on both? Good job, good job. Because y'all, this is g times g. They didn't even say nothing about this f of x on here. Although they're giving us f of x equals x squared minus 4, we're not even using it, okay? Because they want g times g. So good job, y'all. So once again, I get to FOIL. So y'all, x times x is x squared. X times -2 is a -2x. Now let's distribute the -2. So -2 times x is a -2x. And then finally, that -2 times -2 is a +4. So let's see. So Taylor got fixed on that one. Good job. Oh, but you made but the one big mistake on that. Can y'all cancel those out? Because these are like terms, but guess what? They don't cancel out, and you're just going to have a -2 and a -2, which would give me a -4x. So good job, y'all. Because remember, for those to cancel out, you would have to have a +2x and a -2x, okay? If they had opposite signs, then they would cancel, okay? But y'all remember, these are both negative, so you would get your x squared, and like terms, a -4x, and then at the end, you're +4. And there you go. Good job, y'all. X squared minus 4x +4, okay? All righty, y'all. So now they're giving me one with numbers. All right, y'all. So let me get my sheets back. Yeah, you're only going to use FOIL when you're multiplying two things times two things. Sort of like a binomial times a binomial, okay? Now we do bigger multiplication, like two things times three. You do it similar to FOIL, but it would have more steps. So yeah. All right, y'all watch this. Let f of x equal a -8x plus 11. G of x, we're going to let that equal x squared plus 18. We're going to find f of 7 plus g of 7. So a little addition, but they're giving me numbers in place of the variable. That means we better get a single number for our answer. Okay. Now, since they're giving me f of 7 plus g of 7, that's really f plus g of 7, since they're both getting the same variable replaced with the same number. So y'all, I'm going to put my f of 7 here plus my g of 7. F of 7 will be -8 times 7 plus 11. G of 7 over here will be 7 squared plus 18. So it's just a matter of, I'll do it by hand. But when y'all do this, you can put this on the calculator or by hand, either way. So I've got to multiply and then add here, exponent, and then add here. So first, -8 and 7 give me a -56 plus 11. That'll be plus my second parentheses. 7 times 7 is 49 plus 18. All right, so each one of these only has one thing to do. So at this point, I'm going to drop the parentheses. So -56 plus 11 is a -45. And then that'll be plus 49 and 18, which are 67. On y'all, let me see. Kind of what you get, 22. Well, negative 45 plus 67 is 22. So good job on that. And y'all, that's the trick on them. If I give you numbers, I get a single number for that answer, okay? So they're not too bad. You just got to look at what operation do they want me to do on these? And then are they giving me the variable or are they giving me something replacing it with, okay? So let's do one with a little division. So this one, I'm going to let my f of x equal negative 5x plus 9. I'm going to come in with g of x, and it's going to equal x squared plus 16. We're going to find f of negative 4 divided by g of negative 4. So a little bit of fraction stuff going on here. But they're giving me numbers to put into this. So I'm basically going to be finding f divided by g of a negative 4. My f will go on top, so that'll give me negative 5 times negative 4 plus 9. On bottom, g of negative 4 will be negative 4 squared plus 16. Now, where I get people on this one is this negative 4 being squared. So, oh, Taylor, I got you on this one. Undefined. So to be undefined, that bottom has to equal 0, right? So let me ask y'all, what is a negative 4 times a negative 4? Oh, all right, I got you. So Mandan and Rod said, y'all are right. Negative 4 times negative 4 is 16. So y'all, the bottom of that fraction, that's going to be a 16 plus 16. So let me show you what happens when you do this problem on your calculator. So y'all, here's the rule about negative numbers. If you're going to square a negative number on that calculator, you better put it in parentheses. And then when you square it, you'll get the right answer. So negative 4 squared is 16. But if you come in and do it like this, negative 4 and square it, since that negative 4 ain't in parentheses, it's not going to square the negative, and it's going to give you the wrong answer. Because when you square anything, a negative times a negative's got to be a positive, okay? So we always want to keep negative numbers in parentheses when we're squaring them on that calculator so that we get the right answer, okay? And then let's see on top, negative 5 times negative 4 would give me a 20 plus my 9. So y'all be careful about that mistake. I don't care what number you give me. If I square it, it will end up positive, okay? All right, y'all. So that's where I get the biggest mistake. So let's finish this out on top. That's what 29. And then let's see on bottom, 16 and 16 is 32. I don't think that reduces y'all, so that would be our final answer, okay? Okay, Aubrian, I'll let you back in. All right, y'all, on this one, they're saying find f minus g of x when f of x equals 9x minus 5 and g of x equals 3x minus 8. Now notice, they didn't give me a number on this one. So there's no way I'm going to get a single number on this answer. All we're going to be able to do is try to subtract them and then simplify it, okay? So y'all, here we go. F minus g of x will equal my f minus my g. F was 9x minus 5. G was 3x minus 8. So y'all, I'm going to test y'all and see if y'all learned something from that 2.4 support we did the other night. My question for y'all is, what is my next line going to be? What will I write out here as my next line? And y'all, that's a little bit of stuff, so I'll let y'all oh, Catherine, you went too far, girl. So I think you got the right answer, but you're skipping my one step to get to that. So my next line, I would bring out my 9x minus 5, because it don't have nothing in front of it. But on this one, I would distribute my subtraction. Okay, so remember, distribute that subtraction. So a negative and a positive, make that a negative 3x. And then a negative and a negative, make that a positive 8. Oh, actually, I think I got Catherine on that negative 5 and 8, didn't I? All right, y'all. So add the like terms, the 9x and the negative 3x. So good job on that. That was the 6x. And then the negative 5 plus 8. So Catherine, looks like you got it fixed. And negative 5 plus 8 would give me what? A positive 3, okay? So y'all are not bad. You just got to keep up with the order on them. And then watch out for your signs going through here, okay? All right, y'all, watch this. Let f of x equal x squared minus 5. G of x, we're going to let equal. What do I got? Negative 4x plus 5. We're going to find g minus f of x. All right, so my g minus f of x will equal my g minus my f. Well, this one's in reverse order, look. They got g minus f, and g was a negative 4x plus 5. F was the x squared minus 5. So y'all make sure you got them in your parentheses in the right order. So remember, now I'm going to drop parentheses and I'm going to distribute that subtraction. So I want to have a negative 4x plus 5. Negative times a positive makes that a negative x squared. Negative times negative makes that a positive 5. All righty. So what we're going to do, we're going to put it in descending order, and I'm going to add the like terms. So Lexi, on what part are you talking about if you get a negative number? On the final answer? Um, on the final answer. Well, if it ends up being negative, you actually got to keep the negative, okay? I'm trying to think what so right here we would put these in descending order. So the negative x squared is coming first, minus the 4x, and then the 5 plus 5 will make that a 10. So you're looking at a fraction. So here's the rule on fractions. If you got a, say, a negative 96 over 76, you would have to reduce that because they're both even numbers for sure. But if that's a negative, that answer will be a negative, whatever we get, okay? The only way you're going to take a negative away when you're dividing is if oh, I didn't get one yet doing that. The only way I would take a negative away is if I got a negative 96 over a negative 76. If you got two negatives, then they cancel out, making it positive. So this one would be a positive 96, 76. But y'all, if you only got one negative, no matter whether it's on top or bottom, unlike signs would make that stay negative, okay? All right, y'all, let's see here. Let's try one where they throw a little bit of a curveball at us. And I'll see what y'all actually put into my parentheses, okay? So this one, they're giving me a f of x equals x squared minus 3. My g of x equals 12 minus x. So they want us to find f times g of n. So see, they threw a little bit of a curveball. They got a variable here. It's not the x. So that means they want me to put an in for the x's. Remember, whatever they put here, if it's not your variable you're using, then that's what you got to put in for that variable, okay? So let's start this out. We got f times g of n. So I'm multiplying, so I'm putting my parentheses right up against each other. So in place of f, they want me to put an n in for that x. So that's going to give me an n squared minus 3. The second one is my g. Well, they want me to put an n in for its x. So that'll give me 12 minus n. All right, y'all. So another one where we get to sort of FOIL it out. So I'm going to start by distributing the n squared times 12. Well, y'all, that is 12n squared. Now, be careful on the next one. I'm going to do the n squared times a negative n. So a positive times a negative is going to make that a negative. N squared times n. I would add those exponents and get an n to the third. So foiling ain't just multiplying, it's keeping up with them signs too, okay? So the n squared got multiplied by both of these and we're done with it. Let's multiply this negative 3 now. That negative 3 times 12, that's a negative times a positive. So that's a negative no matter what. And then 3 times 12 would be 36. And then finally, this negative 3 times a negative n. Well, y'all, that's a negative times a negative. So that's going to be a positive 3n. So good job, Taylor. Got my n to positive 3n. And y'all, the only thing I can do now is put these in descending order because I do not have any like terms that match up. N squareds, n cubes, and n's. So let's see if Catherine got me right. I got a negative n to the third coming down. I would do my positive 12 n's. So you're right, you just forgot your little exponent, it looks like. And then you would have the plus 3n and then minus 36. But you probably had your square on your paper, or you would have tried to add them together, right? So since you didn't add them together, I'm thinking you had your square there. And y'all, that's all we could do. Foiled it, put it in order. All right, y'all. So that was going through some of these operations you're going to see. So now toward the end, at the last two problems or three, they're going to play with the domain a little bit. So on this part, it says, for the pair of functions, determine the domain of the sum, difference, and product of the two functions. Now my functions are going to be f of x equals x squared, and g of x, let's let it equal 7x minus 4. So what they want me to do is set them up as a sum and figure out what my domain might be. Set them up as a difference and then set them up as a product. So this is like three problems in one. So let's start with the sum. The sum would be f plus g of x. So we're adding them. That's what the sum is, right? Adding. So f will be my x squared plus my g, which is 7x minus 4. Now, at this point, they want us to figure out what our domain will be. Now, if they go to domain, they'll give y'all like A, B, C, D answers. So, y'all, what is the domain of these two functions being added? Y'all got a little domain work earlier this week. So the other day when we did the domain, what was the only thing y'all were concerned about when y'all did those domains in 2.3? So y'all are actually giving me the right answer now because there's no fractions here, is there? And y'all remember the other day we said, hey, the domain of a function is all real numbers unless we have a fraction. And y'all, there is definitely no fractions. So it would be x such that x is a real number. Okay? Now, f minus g of x. That's the difference. That'll equal my f, x squared, minus my g, 7x minus 4. So the question is, what's the domain of these two functions being subtracted, y'all? Oh, Madeline, that's pretty quick. Definitely. It's all real numbers again because I don't have a fraction. So x such that x is a real number. Well, adding and subtraction got to be the same because all we're doing is changing the operation. Neither one of these have fractions, so we're good to go. And then product will be f times g of x. That'll equal my f x squared times my g, 7x minus 4. So do y'all want to try that one? So let's see, Roxy, if you're good, Tater. So all real numbers again. There's no way I can make that into a fraction. So good job. Y'all, we're wanting y'all to realize adding, subtracting, or multiplying, they're always going to have the same domains, okay? If none of these have fractions in them, then it don't matter which of these three operations you do, they're going to be all real numbers, okay? So let me find one they got next here. Y'all, this is the same thing. We're going to find a domain of the sum, difference, and product again. But y'all watch how they change this problem up with just one thing they're doing to it. So f of x is now 1 over x minus 7. G of x is now 2x to the third. So we'll do our sum. That'll be f plus g of x will equal my f, which is 1 over x minus 7, plus my g, which is 2x to the third. So that domain, what would y'all put for the domain on this one? Well, they definitely got to be real numbers, but y'all better check that fraction. Because remember, I got a fraction there, so there might be a number that y'all put into that x that'll make it equal 0, right? So since that bottom cannot equal 0, you can technically set it equal to 0 to see what number you got to exclude. So Madeline, you got a 7 there, and that's it, right? Because if you add 7 to get the x by itself, since I solved it and got a 7, that means my domain would be x such that x is a real number. But because of that fraction, we got to include and x cannot equal that 7. Okay, because 7 minus 7 makes that equal 0. So you got to kick that 7 out of your domain, okay? Any other number I can put in there. I can even put a 0 in there because 0 minus 7 just makes that a negative 7, okay? So the only number it couldn't be was our 7. All right, subtraction, that'll be 1 over x minus 7 minus my 2x to the third. All right, y'all. Give me my domain. It is definitely the same. Good job. I still got the fraction I'm worried about. I can't subtract that from something that's undefined, right? So x is a real number, and my x cannot equal that 7. So just like the one I did a while ago where they didn't give me the fraction, all three of those were all real numbers. Well, all these are pretty much going to be x cannot equal 7s on them, okay? So f times g, because y'all, I still got the same pesky fraction sitting there. Don't matter what operation we got, that fraction is still controlling us, which means that 7 is the only number I can't put into that. So x, so that x is a real number, and x cannot equal 7. So this problem and the one before it, they're going to have the same 3 answers on their domains every time, okay? So the operation they left out was division. But guess what? Your very last problem is a division type domain. For f and g, determine the domain of f divided by g. So y'all, f of x is going to equal 7x minus 10. G of x is going to equal 10x minus 30. So let me give y'all maybe just a little bit of time and see if y'all can find me the actual domain of f divided by g. And then I'll work it out, okay? Oh, Madeline, that's too quick. Y'all rolling them on out. Oh, and I do like your first answer better, though. I y'all, so that was pretty quick on her part. So F divided by G of X technically will be my F, which is 7X minus 10, over my G, which is 10X minus 30. See, I was trying to see if y'all were going to mess with the top of that fraction. But y'all did good. Y'all kept it on the bottom because the bottom's the only thing we're concerned about, right? Just like up here, all we was concerned was with the denominator. So y'all, that's all I'm concerned here. Top can be 0. The bottom can't. So then I would come over here and do 10x minus 30 equals 0. Solve that for x. Add 30 to both sides. So I get 10x equals 30. And then divide by that 10. And that gives me my x. And that's going to give me 3. So 10 times 3 is 30. 30 minus 30 made that 0. So y'all, we're going to kick out that 3. So we get x such that x is a real number. And x cannot equal a positive 3. All right, y'all. So that's pretty much the operations on our functions, okay? We added, subtracted, multiplied, divide. Just remember, if I give you numbers for replacement values, you will get one single number answer. If I give you x's as my variable, and I say find f plus g of x or whatever, well, all we can do is simplify those, okay? And then once in a while, remember, they might throw a different variable in that they want in place of those x's, okay? So we're really controlled by what they're wanting us to put into our functions. And then remember, when you're adding and subtracting, you cannot change variables. Okay? Multiplying, I can change the variables by adding them together, right? All righty, y'all. So, what questions do y'all have of me tonight? All right, so y'all are good tonight?